Hey everyone, hope you're all doing well. Today is lesson 2 in our polynomial unit. We're going to take a look at what it means to be a perfect square, what it means to be a perfect cube, and as well, what it means to take those roots. So we're going to look at square roots and cube roots. Again, I think a lot of this lesson will be, it should feel comfortable to you. It'll be a little bit of review. But again, it's just kind of making sure we're all on the same page, okay? So, cute little warm-up problem here. I'm going to skip through it, but you're welcome to pause and try it yourself. Those are the answers if you had paused and are looking for the answers. Okay, so we're going to start here. Determine the area of the following square. So if this square here is 4 by 4, how do I get the area? Well, I multiply those together. So that's 16. Now be careful, 16 centimeters squared, right? Always remember your units in math, 16 centimeters squared. 2 by 2 is 4 centimeters squared, and 7 by 7 is 49 centimeters squared. Nothing earth-shattering there. What do you notice between the side length and the area? I'm not looking for a rocket science answer here. The area is the square of the side length. 7 squared is 49. 2 squared is 4. 4 squared is 16. So the 16, the 4, and the 49, we call those perfect squares. Perfect squares mean that they are the result of a natural number that has been squared. Okay. It also means I could take the square root of them. I know that the root of 49 is 7. You know that the root of 100 is, that's where you say 10. You scream it like that. You're super, super excited. Yeah, 10. Good job. So a perfect square has as its square root a natural number. I can take the square root of 20. But when I do that in my calculator, it ends up being like 4.47 blah, 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 blah. It's not a nice, pretty, natural number. Okay. So a perfect square has as its square root a natural number. A perfect square is obtaining by taking a natural number and multiplying it by itself. For example, 36 is a perfect square because 6 by 6 is 36, or 6 times 6, I should say, sorry, is 36. We could also say that 6 is the square root of 36. So if we know the area of the square, we could figure out its side length by taking the square root. And this symbol here tells us we're looking at a square root. The root of 36 is 6. Okay, all right, name your first 15 perfect squares. So we're just going right in order. We're going to go 1 times 1, 2 times 2, 3 times 3, 4 times 4. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 25, 16. Sorry, I just realized I skipped that over. 1, 4, 9, 16, 25. I just completely reversed those in my head. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9, 81, 100, 121, 144. Now, most of you, I think, get to here, and we haven't slowed down yet. This is where we start slowing down a little bit. 13 times 13 is 169. 14 times 14 is 196, and 15 times 15 is 225. Especially for some things we're going to do in a couple weeks' time, it would be very, very beneficial for you to commit this to memory, these first 15 perfect squares. Even stuff we're going to do, yeah, well, when we talk about estimating square roots and stuff, which is the beginning of our radicals unit, you really want to have a good foundation on this. So you want to do that sooner than later. Get these first 15 memorized. Okay, now let's look at cubes. Determine the volume of the following cube. Well, how do we get the volume of a cube? We go length times width times height. So we got 3 times 3 times 3, which is 27 centimeters cubed. 3 cubed is 27. That's why we call it cubing a number, because in geometry, it actually creates a cube. And then for 5 by 5 by 5, that'd be 125 centimeters cubed. So again, similar question. Again, not looking for a rocket science answer. What do you notice between the side length and the volume? The volume is the side length cubed, okay? It's the side length multiplied by itself 3 times. So if we know the volume, we can get back to the side length by cube rooting. Okay, so the rooting is the inverse operation of the cubing. A perfect cube is obtained by taking a natural number and multiplying it by itself 3 times. For example, 8 is a perfect cube because 2 by 2 by 2 is 8. We could also say that 2 is the cube root of 8. So the cube root of 8 is 2. Now I want you to notice, based on the last guy, now there's this cute little 3 there. You got to make sure if we're talking about a cube root that that 3 is in there. That's called a root index, and I'll get you to write that down in a second. So if we know the volume of a cube, we could figure out its side length by taking the cube root. All right. So I would like you to have memorized your first 10 perfect cubes. We don't need to go all the way to 15, but we should be able to go to the first 10. So 1 times 1 times 1 is 1. That one's pretty straightforward. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. I'd hope you'd get those 4 at least fairly quickly. Going on to 5. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. 9 times 9 times 9 is 729. And then 10 times 10 times 10 is 1,000. So I'd like you to have memorized your first 15 perfect squares and your first 10 perfect cubes. And a reminder, they're perfect because they're the result of a natural number squared or natural number cubed, okay? All right, so I said I'd introduce a little bit of vocabulary for you. This whole thing here is called a radical. Now, in the next unit, we're gonna dive into this a little bit more, but I wanted to talk about perfect squares and cubes now, just to help out with some of this unit. So the n itself is called the root index, the x is called the radicand, and then the little check mark sign, that's called the radical sign, okay? Now, if we're talking about a square root, like the square root of 100 is 10, the square root of 64 is 8. If we're talking about a square root, we actually don't put a number there at all. If nothing's there, we're talking about a square root, okay? Anything cube root or higher, we would need some sort of root index written there. And you gotta be careful, it has to be inside the check mark, okay? It can't be over here because that means something else. All right, so using prime factorization, determine the square root of 256. Okay, well, the first thing I need you to see is it says using prime factorization. Well, maybe we don't have a clue what we're doing, but the first thing we should do is do what the question says. Prime factorize 256. So this is a good time for you to pause me. You do the prime factorization, and then we'll compare notes. And the prime factorization ended up being 2 times 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 2. So that's 1, 2, 3, 4, 5, 6, 7, 8 2s, or 2 to the 8, okay? Now, what I need you to think of is the fact that you're being asked to do prime factorization. So you're halfway there, you've done prime factorization, but now I have to take the prime factorization and use it to determine the square root. This is an important conversation to have, because if you just go in your calculator, I don't care that you can push buttons in your calculator, right? Anybody can take a calculator and go square root of 256 is, and get the answer. If I'm asking you this on a test, and that's what you do, guess what you get? Nothing, because I want to see the work. I want to see, number one, you know how to prime factorize. Number two, I want to see you know how to take these numbers and show me how to use them to get the square root. So remember that a square root would be a number times itself. So essentially what you want to do is you want to take all of these factors and you want to organize them into 2 equal groups. Now, do we have the ability to do that? Yes, we do. I'd have 4 2s in each group. So the square root of 256 must be whatever 2 to the 4 is, because look at this. This would be 2 to the 4 times 2 to the 4. So that's the same number multiplied by itself. Okay, so the square root of 256 would be 2 to the 4, or 16. So when I ask you to do this on a test, and I will, I want to see the prime factorization, and then I want to see you being able to take all those prime factors and put them into the 2 equal groups, where one of those groups is the square root. Okay? Okay, now you try. Again, we're going to do prime factorization, and then we're going to determine the square root of 576. Go ahead and pause me. Welcome back. I missed you so. So here's your prime factorization. So we ended up with 2 to the 1, 2, 3, 4, 5, 6 times 3 squared. Again, we want to try and put those into 2 equal groups. So if I have 1, 2, 3, 4, 5, 6 2s, I'll have 3 2s in each group. If I have 2 3s, I'll have 1 3 in each group. So each group is 2 times 2 times 2 times 3. Well, 2 times 2 is 4, times 2 is 8, times 3 is 24. The square root of 576 has to be 24. But we've proven why. We didn't just press a button in our calculator. I mean, you can press the button in your calculator and check your answer to make sure you got it right, but this is the sort of work I would need to see if I ask you to do it using prime factorization. Okay, same game, different outcome though. Now I'm asking you for a cube root. So a cube root is a number multiplied by itself 3 times, count them, 1, 2, 3. So I do the same thing, but then I take my factors and I have to put them into 3 separate groups that are equal to each other. So go ahead, pause me, figure out the prime factorization of 729. Good to have you back. Okay, you better be pausing me and trying this because you're never ever gonna learn if you just watch me do it. Okay, so here we go. I got down to 1, 2, 3, 4, 5, 6 3s. I gotta put that into 3 equal groups, so I have 2 3s in each group, which means the cube root of 729 has to be 3 squared, because this would be 3 squared times 3 squared times 3 squared, and 3 squared is 9. Good job. Okay, using the prime factorization to determine the cube root of 5,832, because that sounds fun. Pause me, go ahead and try it. Okay, you should have gotten as your prime factorization something that looked like this. You're organizing this into 3 different groups where there's the same factors in each group. So I've got 1, 2, 3 2s, so 1 2 in each group, 2, 4, 6 3s, so 2 in each group. 3 times 3 is 9, 9 times 2 is 18. So the cube root of 5,832 has to be 18, 2 times 3 squared. Okay, what is the smallest integer? This is another kind of fun question. What's the smallest integer that you could multiply 24 by and get a perfect cube? The goal is not to guess and check this until you get your answer. The goal is to determine. Determine means that you want to arrive logically at a conclusion based on some sort of algebraic work. Okay, so the first thing we're going to do is we're going to prime factorize this. 24 can break down into 2 times 12, which would be 2 times 6, which would be 2 times 3. So I end up with 2 times 2 times 2 times 3. Now, I know that if I want a perfect cube, I have to have 3 equal groups. Well, the 2's are nicely done already, right? If I have 3 2's, I can put 1 there, 1 there, 1 there, perfect, okay? Now, I only have 1 3 though, which means I'm gonna put a 3 here, but I need to get a 3 there, and I need to get a 3 there in order for these numbers to be the same thing. So what I want you to see there is I'm missing 2 3's. If I had a 3 here and a 3 here, this would be the same number times the same number times the same number, which means I need to throw in a factor of 9 here to get a 3 and a 3. 3 times 3 is 9, right? So if I multiplied 24 by 9, I would get a perfect cube, okay? And then you could check your work. You can go 24 times 9. 24 times 9 is 216, and the cube root of 216 is 6, okay? All right, awesome possum. A cube has a volume of 1,331 centimeters cubed. What is the surface area of the cube? Okay, so I've given you volume. What do we know? Well, we know that if we have volume, we're able to get down to a side length. How? Good, to the person who said, I need to take the cube root of that. So make sure you're communicating as you go. I'm gonna take the cube root of 1,331, and that's 11. So I have an 11 centimeter edge length. 11 centimeter edge length. Now, that means I have a cube that's 11 by 11 by 11. okay? And I need to get the surface area of this cube. Well, the surface area is the area of all the surfaces. So I need to get the area of one side, which is that square that I just shaded. That would be 11 by 11, which is 121. So I know that 121 would be the face area, or the area of one square. I wasn't just waving at you there. I was trying to do a face. And then how many of those faces do I have in a cube? Well, I have 6. So I now have to take 121 and multiply it by 6. So the total surface area of this cube would be 726 centimeters squared. Okay. All right, that's it for us on this guy. You can try a few of these, and if you have any questions, you can always seek me down and ask me. That's what I'm here for. That's what I love doing, is asking or answering questions. Okay, so in the meantime, take care, be safe, and I'll see you soon.